There's a number of key ideas associated with the use of water in agriculture. One of them is to diversify the sourcing of water within your farm as much as possible. So ideally any key resource on a permaculture farm should be supplied in 3 different ways. So as far as water goes, that may be the capture and storage of water on your landscape. It may be some availability of natural water resources such as spring water or streams or lakes or ponds within your system that you can extract from in times of need, and also the collection of rainwater and the storage of that rainwater as perhaps your principal drinking water resource on that farm. The other ideas is to do with the purification of water. So before it's consumed by you, that it's purified. So if it's rainwater, it could go through a charcoal filter, for example, that will cleanse out any bacterial infections or debris or other contaminants within that water and make sure it's of good quality before it's being drunk. Or if it's going into agricultural systems or for drunken by animals, that it's cleaned at least through biological systems before it is made available to them. And then after it's been used on the farm, so after it's flown through various production systems to or as it's flown out of the house and been contaminated either as grey water or sewage water, that it's been purified and worked with through biological systems so that those toxins and those nutrients are taken out of that water before it is returned back into the natural water bodies, or purified and then filtered back into production again, so there's a closed loop production system going on. The other thing is the nutrient loading, so all nutrients that are absorbed by plants are transported within water, so water acts as a great way to distribute those nutrients around your production systems and to capture those nutrients within its flow as well. So it's always good on a permaculture farm that's laid out as far as the capture of the water to tie in that capture of water with production systems so that nutrients are also flowing into that water, and then lower down in the landscape where you have more control over the water flow, you can incorporate those nutrients that are in that production into generating productive return through aquaculture systems. So they can be first integrated in with tree crops and grazing systems, and then the nutrients can then be used within aquaculture production and then purified through wetlands before they go back into natural waterways again. So that there's a bit of a holistic view throughout the whole farm as far as how water is sourced, how nutrients are getting into that water, how they can be integrated into different production systems and then cleaned before it leaves the farm. One interesting point with being able to clean water before it leaves natural waterways is the role of holistic management in the whole catchment to be able to do that effectively. So in New Zealand we tend to use riparian planting as a way to moderate the nutrients getting into waterways, but when you consider the great size of most catchments and tiny area devoted into riparian planting, so you've often got a little stream at the base of these catchments and a very tiny area is fenced off close to the banks of that stream and planted. If you've got nutrients through various agricultural production in this catchment and fertiliser use going into this whole catchment, there's very little opportunity for those nutrients to get removed by these riparian trees before they enter into the water. So you really need a holistic view of the management of the whole catchment and the treatment of the water before it enters into these natural waterways and is left. So by all means, riparian plantings can be an important measure to prevent water accessing the streams and rivers and ponds and fouling those water bodies, providing natural habitat and corridors for movement of wildlife between pockets of habitat. So they could be pockets of forest or nature reserves. They could be, if there's high up in the catchment, as you get a lot in New Zealand, you get a lot of native forest reserves, and riparian planting can act as a way for the wildlife to move down streams and rivers into lowland habitats as a corridor for their movement. But as far as nutrients movement through that whole landscape goes, you've got to be aware that you've got to treat the point source of those sources of the nutrients within that whole catchment to be able to manage it effectively. So you've got to incorporate tree crops into that system so that the trees can moderate within this whole catchment the flow of nutrients and the absorption of excess nutrients, so that you're not getting loading of excess nutrients into these waterways, but also within the pasture systems, managing it in a holistic grazing context so that the pasture grasses and herbs get a lot bigger, so that their root system's a lot bigger and they've got more capacity to absorb nutrients out of the soil before, again, they reach the waterways. And also the stocking rate. So one way to kind of manage the stocking rate is to holistically graze it. So if you're allowing your grass to grow up to a certain height and resting that paddock, you can only stock those environments at a certain density to allow that optimum pasture growth to occur. So that forces you to adopt a certain stocking rate that is more in alignment with the carrying capacity of that landscape. So again, that kind of filters into the management of that whole landscape and making sure that it's not being loaded with an excess of nutrients, that the environment is being nurtured in a way that allows it to function in a healthy state and not in a degraded state that's leading to an excess of nutrients leading into the waterways and contaminating the natural habitats. Some of the impacts it has once it enters the waterways, it's often called eutrophication. So it's the excess of nutrients within the waterways, and there's a lot of very sensitive stream invertebrates and fish that if those nutrients are entering into their environment, they can contaminate the environment, so they lead to the build-up of algae, for example, that covers all the stones that a lot of these creatures live and prevents them from obtaining a habitat and a niche within those habitats to acquire the food they need. Instead, they all get covered with a thick mat of algae that prevents them living in that environment and obtaining the food they need. So they get pushed out of those habitats, as well as potentially being poisoned by the nutrients that are in that water themselves. So there's various biological indexes that you can do as far as measuring what macroinvertebrates or stream insects there are, or fish that are sensitive to water pollution, and you can use those biological indexes as a gauge of the use of that whole catchment and the contaminants that are getting into that catchment. The other issue that's common is that with a catchment being overgrazed and the stock damaging the soil and pugging the soil with their feet, it leads to a lot of sediments moving through that landscape and entering into the waterways, and those sediments also clog up the stones and other habitats that those freshwater creatures occupy, and again forces them out of those habitats because they've been detrimentally impacted, preventing them from living.